What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to go through a simple linear regression example. And more specifically, we are going to build a machine learning model that predicts car prices. Now, in order to do this, we are going to follow this process you see over here. On the development phase, we are going to load our raw data, and then we are going to go through all the data pre-processing steps, which is data cleaning, dealing with missing values, aggregating our data, and visualizing our data. Then we are going to go through the data modeling phase, which is basically running correlations and feature importance, running our machine learning models, and also storing our models and our results. And down here, we have all the code we are going to use for this phase. Right, going back at the top, then we have the deployment phase, and this is where we are going to build a Streamlit app and also a Power BI dashboard. In the Streamlit app now, which is this app over here, the user can actually input values. So for example, 500 horsepower, click enter and click predict, and this is going to give us a prediction based on all these selections we have over here. And this is actually calling our model, which we have trained and stored in the code over here in the development phase. We are also going to develop a Power BI dashboard, which is this dashboard over here, where we have all the predictions based on our current data. So we don't have the ability to input different values. However, we are predicting on our actual data. And this is so the business can actually see all the important variables that affect the car price and also see which cars are we overpricing or underpricing. Right, going back, and before we start this video, let me just say that if you're passionate about data analytics and data science, then please consider liking this video, subscribing to my channel, and enabling notifications for my future videos. Right, starting with the machine learning process. So very quickly, this is the process we are going to follow, and this is actually the process you always follow when it comes to training machine learning models. So first, we need to formulate our problem. So write down what are we trying to solve. Then we need to gather our raw data. We need to go through the data pre-processing steps. We need to split our data. Then we need to select our model. Then we are going to run and evaluate our model. Then we are going to run some hyperparameter tuning, assuming the model allows this. And then we are going to repeat this process until we are happy with our parameters and our model performance. We are going to store our final model and we are going to deploy it either the predictions in the dashboard or in a web app like Streamlit, which is what we're going to do over here. This is our web app and we have deployed our model. Right, going back, the problem we are trying to solve is that we are trying to understand which variables affect the car prices. We also want to be able to predict car prices. So this is the two things we are trying to solve with this video. Starting with our raw data now, over here we're just reading our raw data, which is some car data I have scraped from the web. If you want to see how I have done that, I'm going to have a link in the video description where I show how you can use Beautiful Soup in order to scrape some data and store the data either in SQL or in a CSV file. Right, let me run this quickly. So if we check our car data now, which is in this data frame, you can see we have the make, which is basically the manufacturer of the car. We have the model, the year, the trim, the MSRP, the invoice price, the use price, body size, body style, cylinders, engine aspiration, drivetrain, transmission, horsepower, torque, and then highway fuel economy. So we have all these variables, and the price we are going to try and predict is this manufacturer's retail price over here. So this is our Y variable, and everything else we are going to use as input values. Right, moving on, we have the data pre-processing steps, and this is where we are trying to understand all of our data. So the first thing I always do is that I run this piece of code over here, which what it does, it goes through all the columns in our data frame. It counts the number of unique elements in each column, and then if the count of unique elements is less than 12, I'm actually printing those elements. So this is for our categorical values, so I'm able to see and understand our data. So as you can see, for the first column, which is index, we have 1610 rows. For the second column, which is the make, we have 7 distinct makes, which is Aston Martin, Audi, BMW, Bentley, Ford, Mercedes, and Nissan. For the number of models, we have 150 number of models. So this is telling me that for the same model, there is a lot of different variations. Maybe it's like the year, the trim, the price, the body size, or the body style, or anything else. Down here, we can see body size. We have 3 distinct body sizes. Body style, we have 12. Then cylinders, we have 10 different options. Engine aspiration, we have 6 distinct options. Then for drivetrain, we have 4. For transmission, we have 2. And the rest is basically numeric values. Right, the next thing I always do is that I check for missing values. And in order to do this, we can say car data, which is our data frame, .isNow.sum, and this is going to count the number of missing values for all the columns. As you can see, for invoice price, we have a lot. Then for cylinders, we have some. And then for horsepower, torque, we have a lot less. So these two we can actually deal with, but I think for the rest, we can safely drop these columns just because based on the total number of data we have, which is 1610 rows, we are missing a lot of these missing values. So down here, when I'm saying dealing with missing values, I'm actually dropping the invoice price, which is this one, which we have a lot of missing values. I am dropping the cylinders, which again, we have a lot. And I'm also dropping the highway fuel economy, which is this one right here. So if I run this again, and then if we visualize our data frame, we are not going to have those columns. So if we check, you can see we don't have invoice price, cylinders, or highway fuel economy. Right, the next thing we have to do now is to deal with these 2 columns over here, which we have some missing values, but they are not a lot, so we can actually do something to replace them. So for horsepower NO, if we quickly visualize our data, you can see that it has the horsepower number, but also the RPMs. However, we cannot use this in a calculation because this is a text and not a number. So we can't really use the average to replace the missing values. First, we have to extract the number of horsepower, and then we can use the average in order to replace the missing values. To do this, what I'm doing over here is that I am selecting the first 3 characters, which is basically the number. And then I'm setting the type as float, and then I'm storing this new number now into horsepower NO. So if I run this quickly, so you can see the data again, so enter, run, head, you can see we have extracted the horsepower number from horsepower column. Next, we are going to view all the null values. So we want to view all these 5 missing values for horsepower. In order to do this, I'm just selecting everything from our data frame where the horsepower NO is null. So you can see it's all for Ford cars. So the reason I'm doing this now is because when I'm going to replace the missing horsepower with the average horsepower, I don't want to use the average of all the makes. Since it's only the Ford makes, then we can use the average for Ford in order to replace the horsepower NO, which is what I'm doing over here. I am calculating the mean horsepower for all make equals Ford. So this is just for Ford cars. And then what I'm doing here is that I am filling all the NAs for horsepower NO with the mean, which is what we have just calculated. So if I run this quickly, so you can see the mean, so you can see the number basically. So let me copy and then paste. You can see this is the mean horsepower for Ford makes. And then let me remove this because we don't need it. We need that, yeah. So I'm filling all the NAs with the mean horsepower. And I'm also filling all the NAs for horsepower column itself, which is the one with the text. So I don't have any null values when it comes to horsepower and horsepower NO. As you can see, we have cleaned it. And now we need to do the same for torque. So if we visualize the data again quickly, so let me copy this over here, head. I think torque is also a text. Yeah, that's correct. You can see torque is also a text. So it's exactly the same process. First, we clean torque by taking the first 3 characters and storing that into torque no. Then we want to view all the missing values. So let's actually view them. Copy this and let's paste. Yep. So if we check all the non-torques, is not just Audi cars. You can see we have BM over here, we have Ford and Audi. So we cannot really repeat the same process as we did before. So I think we're going to take the mean for all cars. So this is the mean torque for all cars. And we're going to fill in the torque columns with the mean torque value, which we have calculated over here. And then if we run this, we can see we don't have any missing values anymore. Right, moving on. The next thing we want to do now is to clean the data types. So if we run the data frame and then the data types, you can see we have a lot of object columns, which basically they shouldn't be an object because they are numbers. So if we view the data again, so .head, first one, you can see the MSRP, for example, is actually a number in here. However, in our data frame, MSRP is an object. So we have to clean MSRP, we have to clean the used and new price. What else do I have over here? Yeah, these two, we have to clean them so they are actually values, so we can actually use them in calculations. So what I'm doing over here is that I am just replacing the $sign with empty, and I'm also replacing the comma with empty, and then I'm turning this into float. So if I run this again, and if I run our data types, you can see that MSRP now is float and used and new price is also float. And if we visualize the data again, you can see that we don't have the $signs or the commas anymore. This is now a number where we can aggregate or feed into a machine learning model. Right, let me remove this and let's move on. The next thing we want to do now is to visualize our data in order to identify any relationships. So the first thing I always do is that I run pair plots on my whole data set, assuming it's a small data set. If I have more than 20 features, then I'm going to break it down and run chunks of data in pair plots. Right, so as you can see, this is all of our pair plots. The important column for us is the MSRP, which is this column over here, which is going to be our target variable. So as you can see, the two features that stand out that affect our MSRP, that is kind of a linear regression shape, is these two plots over here, which is basically the horsepower number and the torque number. So what this is telling us is that as we increase the horsepower, the price of the car is also going up. And it's the same case with torque. For the rest of the plots, we're going to have to dig deeper in order to identify more relationships. So what I'm doing over here is that I am selecting the features I have identified that have a relationship with MSRP, and then I'm plotting them using some categorical variable in order to see if there is any relationship. So I'm going to start with engine aspiration, what values does it have? Let me check. Engine aspiration has these values over here. The electric motor, naturally aspire, supercharged, turbocharged, twin turbo, and twin charge. And if we check the relationships, which is, there we go, this one over here, you can see that cars that are twin turbo, they are a lot more expensive. And then in the next visualization, I am breaking down the cars, so it's the same graphs, but this time I am using make as our legend. So if we check this, we can see that all these expensive cars over here, they are all Bentleys. So they're actually outliers. However, because we can actually use make in order to model those outliers, we are going to keep them in because the model can easily use, as I said, make in order to distinguish that these cars are going to be, on average, a lot more expensive. Right, the next visualization I'm going to do is that I want to visualize all of my categorical variables. And over here, I have a list with all of my categorical variables. And what I'm doing is that I am creating these bar plots, which is this bar plot you see over here, where y is my MSRP, so our target variable, and x is all of my categorical variables, which we are going to look through, and we are going to plot these bar charts. So we can see over here, let me actually do this so we can see the whole thing. So we can see here that Bentley and Aston Martin, the sum of MSRP is actually the higher, and then for the rest of the cars we have a lot lower sum of MSRPs, and this is because these cars are in general more expensive. We can see the body size, we can see the body style, so these convertible are on average more expensive. As you can see, also the coupe is on average more expensive. Over here we have the engine aspiration, twin turbo more expensive. Then drivetrain, we can see all-wheel drive cars are more expensive. Transmission, we can see that automatic cars are more expensive. By the way, I think I'm using the sum, not the average. So this is also dependable on the number of cars we have in our dataset per make. So just keep this in mind. We can actually change this to be the sum, but I'm not going to do it now. Right, moving on, the next thing we are doing is that we are investigating the distribution of all of our numeric fields, which is the MSRP, the new use price, the horsepower NO, and the torque number. So if we go through the code, what I'm doing is that I'm looping through all of these variables. Then I store the values of this variable in X, and then I'm creating this plot, which is this plots you see down here. And I'm also calculating and adding this red line you see over here, which is the average. So this plt.axv line is basically plotting this line over here. So starting with the distribution of MSRP, which is our target variable, you can see that it's not a bad distribution. However, we have these outliers on the right hand side, which is basically all the Bentley cars we have seen in the previous plot. So we don't want to take action on it because we understand it. We don't want to exclude it because we can actually model it. Then checking the use and new price is the same case. Horsepower, good distribution, normal distribution. Torque no, normal distribution. So again, everything is fine here. We don't want to take an action. Right, moving on. Another way of investigating the distribution of numeric variables is by creating these box plots you see over here, which they basically do the same thing as the previous step. They are giving us our normal distribution and then all the outliers. However, because we have identified that these outliers is mostly because of the Bentley expensive cars, we are not going to take an action on it. Right, if I remove this, the next step we want to do is to investigate the distribution of all of our categorical variables by our target variable, which is MSRP. So what we are going to do now is that we are going to create these box plots, the same box plots as before. However, we are going to break them down by all of our categories so we can see the distribution per categorical variable. And we are also going to plot this swarm plot over here, which is all of our data points for MSRP, which again is our target variable. So if we view the results over here, let me expand this, you can see that we get the distribution per make, and we also get all the data points we have. So you can see the distribution for Bentley cars is significantly higher, the MSRP, from all other cars. However, it's not a bad distribution as it doesn't have any outliers. The other makes though, they do have outliers. As you can see, all of them have a few outliers, and this is because some of them come with much bigger engines than others. So this is actually, I'm not going to remove any of these outliers because I know that the same make, like Nissan, can have both a 500 horsepower car and a 300 horsepower car. Right, so if we check the other distributions, yeah, you can see they all have outliers, but we can explain the outliers. Body style, yeah, you can see distributions. Then engine aspiration is okay. Drivetrain also okay. Transmission, yeah, all seems good. Right, moving on, the next step we have now, let me go back, is that we have to prepare our final data frame in order to feed it into our models. And to do this, there is a few things we have to do. So if I investigate this quickly, so you can see all the columns. First, we have to remove the index, as this is just a number per row. It doesn't mean anything. So this is what I'm doing over here. I am also dropping the model, since we have a lot of different models. I think we have 150 something different models, and they are going to take a lot of processing power if I am to use model in my machine learning model. However, I'm just going to remove it for now. Next, I'm removing year because we only have 2023 and 2024. If we had a lot more years, I was going to keep it. Then I'm removing trim because, again, I have a lot of different trim options and they are very specific per model, so they are not going to help me in my predictions. I am removing the used and new price because it's basically almost exactly the same as MSRP. I'm removing the horsepower text column because we've created the number column. And the same case with torque, I'm removing torque because we created this new torque column. Next, I need to turn my data into numeric representation. So very quickly, let me show you now the data we have. So if I do this and then we do this, dot head and then visualize, you can see we have removed all of these columns. And now we have to turn our categorical variables, so all the columns that are categories, into numeric representation. And to do this, I'm going to use get dummies and then pass all the categorical columns. And if we visualize this quickly, you can see that, for example, for make, it created 5 new columns, 1 per element of make. So this is make Aston Martin, true or false, make Audi, true or false, make BM, true or false, make Bentley, true or false, make Ford, make Mercedes, make Nissan, true or false. And then it repeated the same process for all of our categorical variables. So it created new columns, true or false, per element of that feature. So now our data frame is ready to be fed into a model, which is basically our next step. Right, and down here I start with the correlations and the feature importances. So first I select my continuous numeric variables I want to correlate, and from my main data set I'm selecting these n variables. I run .core and the method is Pearson correlation. I store the n variables, which is the column names, into calls over here because I'm going to use them in my heat map. And then down here, I am plotting this heat map with my correlations. So this is the Pearson correlation dataset. So if we run this quickly, you can see that MSRP has a high correlation for horsepower NO, 0.7, and also an average to high correlation for torque NO. So this is good to see. It means that they are going to be good predictors of the MSRP price. Right, the next thing I do is that I run feature importances, and in order to do this, we have to train and run a tree-based algorithm. And in order to do this over here, I am splitting my data into X and Y. X is all my variables excluding my target variable, and Y is my target variable, which is MSRP. Over here, I initialize and then I feed my decision tree classifier. So if I run this quickly, and then down here, I'm just calculating the feature importances per column, and then I'm storing them into this final DF, and then down here, I'm just visualizing the final DF. So if I come down here into the data frame, which is this one over here, you can see the variable, and then you can see the feature importance, and this is actually sorted highest to lowest. So the most important feature when it comes to predicting price is actually the horsepower number. Then is a categorical feature, which is the make Ford. Then is the torque number. Then is the engine aspiration turbocharged, and then it goes on and on over here. And if we scroll at the end, we can see that these two features, they don't give me any information gain in our data, so they don't really contribute to anything. Right, moving on, the next step now is to use holdout validation, which is basically splitting our data into these 4 subsets. And what this is doing is selecting 80% of the data to be as our training data, and then storing it into X train and Y train. And selecting 20% to be our test data and storing it into X test and Y test. So if we click run quickly, you can see that we have 1,288 rows or observations on our training data set, and we are going to use 322 observations in order to predict on unseen data. So the model is not going to be trained on this data set over here. Right, moving on, the next step now is to run our regression, which is our machine learning model we are going to use for this video. And the way it works is that it iterates through all of our features and it plots all these lines. It calculates the residuals, which is the difference between the actual data point and the line, and is trying to find the line of best fit that has the lowest residuals. And that line is going to be our regression line, which is y equals a plus bx. Right, to do this, I'm using linear regression from sklearn, and then I'm feeding it into our xtrain and ytrain. I am making a prediction with our new model, and then down here, I'm making a prediction on our training dataset, and I'm also making a prediction on all of my dataset because I'm going to need this for Power BI later on. So if I run this quickly, and then down here, I want to evaluate my model. So I have the model accuracy on my training dataset. I have the model accuracy on my testing dataset. So this is the unseen data. I have the root mean square error again on both the training and the testing. I have the mean absolute error on both the training and the testing. I have the coefficients, and I also have the intercept. So if I run this quickly, we can see that we have an R square on the training data set of 0.89%, which is very good, it's close to 1. And I also have an even higher R square on my testing data set. So this is unseen data. So the model actually does very well. Down here, I have the root mean square error, and this is telling me that on average, my prediction of MSRP, which is the retail price, is going to be 17K off for my training dataset. And then for my testing dataset, it's going to be lower, which is good. The lower, the better. It's going to be on average 16K up or down, so outside the actual price. Right, now that we have a good model that actually predicts very good on both seen and unseen data, we want to store our model in order to be able to call our model in our app over here and make predictions. To do this, you need to run this code over here. So with open, pass the name of the file you want to export as f. You want to do pgold.dump, and you want to pass your model, which is this model over here. We have just trained, and then comma f, and this is going to create a new file. So if I show you quickly, this is the new file it's going to create that we are later going to call into our Streamlit app in order to make predictions. The next step I'm doing over here is that I am storing my feature importances data frame. So first I round the features into 4 decimals, then I'm selecting the first 27 features because the last 2 features, they don't contribute anything to our model, so I don't really want them. And then I'm exporting this data frame into this Excel file over here. And then I'm repeating the same process for all of my data. So this is my main data, but before I do this, I'm also passing the predictions back to all of my main data. So this all df.predict is actually the predictions on all of our data set, not just xtrain and xtest. This is actually predicting on all of my data, and then it stores it back to my main data frame. So I can then use to build this Power BI dashboard from scratch. Right. The next steps now is to actually create the Streamlit app and deploy it, and then create the Power BI dashboard and deploy it. However, I'm not going to do this in this video. I'm going to create 2 new videos. One is going to be for the Streamlit app, and the other one is going to be for the Power BI development and deployment. So if you check the video description, I'm going to have links to those 2 videos. Right, so I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos. If you have any questions or ideas, please let me know in the comments below. Thank you very much for watching this video.